As you remember, for function f to be continuous at a, you need to have three conditions met. First of all, f of a must define. It means that a must be in the domain of the function. Second of all, the limit must exist when x approaches a. 3, the limit and the y value must be equal to each other. So these three conditions are super important. Suppose you have two continuous functions like f and g. Their addition, their difference, scalar multiplication, their multiplication. The division, assuming that the denominator is not equal to 0, so this part is important. And also, if you take the function and raise it to power n, they are all continuous functions. For polynomials and rational functions, polynomials are continuous everywhere. For rational function, you just need to be careful. The denominator cannot be equal to 0. When it comes to composition of two functions, if f and g are continuous function, basically g is continuous at a and f is continuous at g of a, then their composition f of g is continuous at a. We can also discuss continuity at endpoints. A function f is continuous from right if the right limit of the function is equal to the y value of the function. And we also say that a function is continuous from left if the left limit of the function is equal to the y value of the function. Visualizations for you. Here, your function has right continuity at a. Take a look. If you're getting closer and closer to a from right-hand side, the limit from right is equal to the y value of the function. For this one, you have continuity from left-hand side. Here, when you're getting closer and closer to a from left-hand side, the y value of the function and the limit from left at b are equal to each other. And finally, in this case, as you remember, you have a jump discontinuity. The function, which is right continuous, but it is not left continuous. In this case, it is located at the origin. We say that, hey, it has a jump discontinuity. So we are generalizing these ideas to multivariable functions. If you have a function of two variables, this is called a continuous function at, take a look, ordered pair A and B. If the limit of the function is equal to the z value of the function, we say that f is continuous on domain D if it is continuous at every single point in that domain. So please note that here you need to find the limit of the function and show that the limit of the function is equal to the z value of the function. For example, where is the function continuous? Here you have a rational function. When you have a rational function, we need to be careful about the denominator. Let us take a look at the domain of this function. The function f is discontinuous only at the origin. Why is that? Remember the domain of this function. Since it's a rational function, the denominator cannot be equal to 0. So you can basically write the domain as the set of all ordered pairs such that x and y cannot be equal to 0. But again, please pay attention to your denominator here. X squared plus y squared, and this cannot be equal to 0. The only point that make the denominator equal to 0 is at the origin, and we need to eliminate that from the domain. Now that we discussed the continuity of this function by looking at the domain, I expect you to ask, what if I extend this function? So when you're adding 0 and 0 to the domain and you are setting the z value equal to 0, you're basically looking at the extension of this function. But now that you have the extension of the function, is this still continuous? G is defined at the origin, but again, G is not continuous at the origin. So remember that to be continuous at a point, you have to have the limit exist. Remember how we discussed this. If you set x equal to 0, then you have a constant function z equals to -1. And when your y is equal to 0, you have a constant function z equals to 1. These two are not equal to each other. So basically you have different limits. So since the limits are different from each other, you can easily say that the limit doesn't exist. So you don't have continuity here.